Remote Desktop Protocol, or RDP, is one of those technologies you're going to use constantly in IT support. By the end of this module, you'll know exactly how RDP works under the hood, what port it uses, and why that matters, and how to troubleshoot the most common connection failures. This is practical knowledge you'll use every single day on the help desk, and it's absolutely tested on the exam. RDP is Microsoft's Remote Access Protocol, which means when you're supporting a user who's working from home or you need to fix something on a server in another building, this is your tool. RDP is a client-server protocol that gives you complete graphical control of a remote Windows machine. When you connect via RDP, you're not just getting a command line. You see the entire desktop, you can run applications, you can configure settings, and to the person using it, it feels almost identical to sitting at that physical machine. Under the hood, RDP works by sending your keyboard and mouse inputs to the remote computer, and the remote computer sends back compressed screen updates showing you exactly what's happening. It's incredibly bandwidth efficient because it doesn't stream raw video. It only sends the parts of the screen that actually changed. The protocol rides on TCP port 3389 by default, which is a detail you absolutely need to memorize for the exam. TCP is the right choice here because remote desktop sessions require reliability. If packets get dropped, your session would corrupt or disconnect. Now here's something critical to understand about RDP versus other remote access tools. RDP is built into Windows Professional and Enterprise editions, but it's not included in Windows Home. That's a classic exam trap. If a user has Windows 11 Home and asked why they can't enable remote desktop, that's why. They need to upgrade the license. RDP also requires network-level authentication by default, which means the user has to authenticate before the session even starts. This is a security feature that prevents brute force attacks at the login screen. Let's talk about port 3389 specifically, because port numbers are a huge part of Objective 2.1. A port is essentially a numbered channel that tells network traffic where to go once it reaches a computer. Think of an IP address as a building street address, and the port number as a specific apartment number inside that building. When you type an IP address followed by :3389, you're telling your computer to connect to that machine's remote desktop service specifically. Now, 3389 is the default listening port for RDP. That means when you install Windows and enable remote desktop, the RDP service automatically starts listening for incoming connections on TCP port 3389. If a firewall is blocking that port, your connection fails, period. That's the number one troubleshooting step when RDP isn't working. Check if port 3389 is open on both the local firewall and any network firewalls between you and the target machine. You can change the default port for security reasons. Some organizations do this to reduce automated attack attempts. But you need to change it on both the server side and the client side, and you need to specify the custom port every time you connect. For the exam, just remember the default RDP equals TCP port 3389. Now let's walk through what actually happens during an RDP connection, step by step. First, the client initiates a TCP handshake on port 3389. That's the standard three-way handshake, SYN, SYN, ACK, ACK, establishing a reliable connection. Second, the server sends a security negotiation, where both sides agree on encryption settings and authentication method. This is where network-level authentication happens if it's enabled. Third, the user authenticates with their credentials, and if that succeeds, the server sends the desktop session data. Your screen, your applications, everything. And fourth, from that point on, the connection is persistent. The client sends input events, the server sends screen updates, and the session stays open until you disconnect or the connection drops. One thing people often misunderstand: when you're in an RDP session, the applications are running on the remote machine, not on your local machine. Your laptop is just displaying the output and sending your inputs. That means if you disconnect, the session doesn't necessarily end. It can stay running on the server, and you can reconnect later and pick up exactly where you left off. That's actually a feature called session persistence, and it's incredibly useful for long-running processes. So let's talk about the most common RDP troubleshooting scenarios, because this comes up constantly in the field. First scenario, user tries to connect and gets remote desktop can't connect to the remote computer. 9 times out of 10, that's a firewall issue. Check Windows Firewall on the target machine. There's a specific rule for remote desktop that needs to be enabled. If that rule is disabled or deleted, port 3389 is blocked and the connection fails. Second scenario, connection works, but then it immediately disconnects after login. That's usually a licensing issue. Windows has a limit on how many simultaneous RDP sessions are allowed, and if that limit is hit, new connections get kicked. On Windows Pro, you can only have one active RDP session at a time. On server editions, you can have multiple sessions, but there's still a limit based on licensing. Third scenario, connection is slow or laggy. That's almost always bandwidth or latency. RDP is efficient, but if you're on a cellular hotspot with high latency, the experience degrades fast. You can reduce the color depth and disable visual effects in the RDP client settings to improve performance. And here's a classic exam question. What happens if the remote machine is asleep or hibernating? Answer: RDP won't work. The machine has to be powered on and awake. Some organizations use Wake on LAN to wake machines remotely before initiating an RDP session, but that's a separate technology. Now let's talk about security, because RDP is a massive attack surface if it's not configured properly. Here's the reality. Exposing RDP directly to the internet is one of the most dangerous things you can do. Attackers constantly scan for open port 3389 and attempt brute force login attacks. That's why network-level authentication exists. It forces authentication before the session starts, so attackers can't even get to a login screen. But NLA alone isn't enough. Best practice is to never expose RDP directly to the public internet. Instead, use a VPN to establish a secure tunnel first, and then RDP over that tunnel. Some organizations use Remote Desktop Gateway, which is a Microsoft role that acts as a secure proxy for RDP traffic. Or you can use an SSH tunnel to forward port 3389 through an encrypted channel. Another common approach, change the default port from 3389 to something obscure, like 33890. That doesn't make RDP itself more secure, but it does stop automated scans from finding it immediately. It's security through obscurity, which isn't a replacement for real security, but it's a useful additional layer. And finally, always use strong passwords and consider enabling account lockout policies to prevent brute force attacks. If you see repeated failed login attempts on port 3389 in the event logs, that's a sign someone's trying to break in. So here are the 3 takeaways you need to lock in. First, RDP is TCP port 3389 by default, and that port must be open in firewalls for connections to work. If you remember nothing else, remember that number. It's on the exam, it's in the field, and it's the first thing you check when troubleshooting. Second, RDP gives you full graphical control of a remote Windows machine, but the applications run on the remote side, not your local machine. That means session persistence is possible. You can disconnect and reconnect without losing your work. And it also means if the remote machine is asleep or off, RDP won't work. Third, never expose RDP directly to the internet. Use a VPN, use Remote Desktop Gateway, or tunnel it through SSH. Attackers love open RDP ports, and brute force attacks are constant. Network-level authentication helps, but it's not enough on its own. Combine it with strong passwords, account lockout policies, and network isolation, and you've got a reasonably secure remote access solution. That's RDP in a nutshell. And now you're ready to configure it, troubleshoot it, and ace the exam questions about it.